Hello, how are you? I'm really excited about this one because we get to talk about electromagnetism. And so we're going to share the screen here just for a moment and talk a little bit about what electromagnetism is. Okay, so electromagnetism, and we're in week 4. So right here, we've got a dog. And this dog, no, he's not electromagnetic, but he is a pretty smart dog. He wants to go in. It's been raining outside. He's all wet. He's cold. He's muddy. And he's tired of being outside. So he wants to go in. So he's decided that he's going to ring the doorbell. What a smart dog, huh? So question, does your home have a doorbell? And if it does, do you know how it works? Have you ever wondered how it works? Well, to be quite honest, the answer for how it works is electromagnetism. Electromagnetism is magnetism produced by an electric current. When electricity flows through a wire, it creates a magnetic field that circles the wire. So as you look at this diagram, the green, if you imagine the green, I know it looks like you can see through it, but it's actually all one wire. So that green is just the outline of the wire. And electrical current is passing through the wire. And because it's passing through the wire, it forms a magnetic field around that wire. So as you can see in the diagram, note that the electrical current is conventionally shown moving from the positive to the negative potential. However, electrons in current actually flow in the opposite direction, from the negative to the positive potential, okay? So, quick question. If more current flows through the wire, how might this affect the magnetic field surrounding the wire? So if we send more electrical current through that wire, how is that going to affect the magnetic field? Well, the answer is, with more current, then the magnetic field is stronger. Okay. In electronics, there's something we call the right-hand rule, okay? And the direction of a magnetic field created when current flows through a wire depends on the direction of the current. Let me say that again. The direction of the magnetic field created when current flows through the wire depends on the direction of the current. So a simple rule to remember is what we call the right-hand rule. And it makes it easy to find the direction of the magnetic field if the direction of the current is known. So what I want you to do is, I want you to hold out your hand. Okay, here's my right hand. Okay, I want you to hold out your hand, and I want you to curl the fingers in with the thumb extended. Okay, curl your fingers in with the thumb extended. Now, when the thumb of the right hand is pointing in the same direction as the current, so let's say the current in this wire, we got a wire in my hand going up and down. In fact, so you can visualize it even better. There's my wire, okay? I know, it's a pen. We imagine things, it's okay, okay? But you're hanging onto the wire, okay? And your thumb is pointing in the direction that the current is going. The current's gonna go from down here up. It's gonna go up in this wire, okay? The fingers of the right hand curl around that wire, don't they? The direction that they curl around the wire is the direction of the magnetic field. So if the current is going this way, the magnetic field is coming around this way. All right? So try that with a pencil and with your hand, and you'll be able to see which way the magnetic field is traveling. Let's go back to this, and we're going to watch a quick video clip about the right-hand rule. Hopefully helps you understand even better. So that was an absolutely riveting movie. I hope you enjoyed that. And we're going to go on to the next point, which means we're going to skip down here. Not quite where we want to be. There we go. Okay. So electromagnetism is not only used in doorbells, but many other electric devices as well, such as electric motors and loudspeakers. It is also used to store information on computer disks. An important medical use of electromagnetism is the magnetic resonance imaging, or MRIs. This is a technique for making images of the inside of the body in order to diagnose diseases or injuries. Magnetism created with electric current is so useful because it can be turned on and turned off. Also, you can change the amount of strength of the current and thereby change the amount of magnetism, the strength of the magnetic field, by changing the strength of the current moving through it. You can't do either of these things with a regular magnet. So, really quick, in summary, electromagnetism is magnetism produced by an electric current. When the right hand thumb points in the direction of the current, the fingers curl around the wire in the direction of the magnetic field. Electromagnetism is very useful because it can be turned on and off by turning on and off the electric current. Also, it can be made stronger or weaker by using more or less current. Feel free to pause this video and record these summary points in your notes so that you can refer to them in the future. I appreciate you being here, and we will talk more about electromagnetism as the week goes on. So I hope you enjoyed it, and we'll see you again. Have a great day. Stay healthy and stay happy.